All right, so here's our first question. Example 10. The traffic flow at a particular intersection is modeled by the function f defined by f of t equals 96 plus 5 sine t of t divided by 2 for 0 to 30 minutes. So we're just looking at the traffic flow for 30 minutes. What is the average rate of change of the traffic flow over the time interval from 3 minutes to 8 minutes? Indicate the units of measure. What does this rate tell you about the flow of traffic during this time? All right, so average rate of change is going to be f of 8 minus f of 3 divided by 8 minus 3. So we are going to have to find f of 8, which is 96 plus 5 sine. So 8 divided by 2 is just 4. Let's just plug in 4. 4. What did you get for 96 plus 5 times sine 4?
96, 4. I got 96.3488.
96.3488. And then how about we have f of 3?
96.1309.
What was that again? I'm sorry. 1309. All right, so there is our two values there, and we'll plug those in. So we have 96.3488 minus 96.1309. Ooh, that's awful close. Let's move this over a bit. All right, and then all divided by 8 minus 3 is 5. We're going to plug this into a calculator and get a decimal approximation there. May as well not leave that as a fraction since it's already got lots of decimals in it. There's a decimal point in here. I think it's sort of lost. There we go. All right, so someone plug that into a calculator, and what do you get as a decimal? 0.2179. And we need our units of measure. Anytime you've got a real world problem, it needs units of measure. That is, all right, we have minutes. Cars per minute.
Divided by 5 as well?
Yeah.
Oh, okay.
Don't write that down, class.
0.4358.
0.04358. We forgot to divide it by 5. All right, so that is cars per minute. All right, we're measuring cars. So, maybe traffic's pretty slow there. What does this tell you about the flow of traffic during this time? All right, so it's positive. So there are cars going through. It's just slow. So I'm going to put this up top here. So cars are getting through. The intersection, and we know that because the average rate of change is greater than 0, but it appears slow. Maybe there is an accident slowing down traffic. Or traffic jam. Is it possible to find the rate of change at a specific time? Well, using average rate of change, using our tools, the tools for pre-calculus, sort of. All right, so we can approximate the average rate of change. Let's call it the rate of change. Let's get rid of the word average. Just the rate of change. The rate of change, because average rate of change implies secant line, and rate of change at a specific time implies tangent line. So let's just get rid of the word average. We can approximate the rate of change at a specific time by taking or using closer and closer values. With average rate of change. So the average rate of change approximates what's called the instantaneous rate of change. Instantaneous rate of change is the rate of change at a specific moment. Let's explore the rates of change at 2 points over small intervals. Estimate the rate of change of traffic flow at t equals 8 by finding the average rate of change from 3 different intervals, from 8 to 8.1, from 8 to 8.01, and from 8 to 8.001. Right? All right, so we're going to have to get our values here first. Let's have to squeeze this in. All right, so we know what f of 8 is, because that's up there. That was 96.3488. So we're going to need f of 8.1. And I'm not going to write the whole equation. We don't have a lot of space here. F of 8.01 and f of 8.001. But what we're doing is we're just plugging that into the equation up here. So somebody plugged that into calculators. And what did you get for f of 8.1? What did you get for f of 8.1? So it would be, I'll write it up here. It would be 96 plus 5 sine 8.1 divided by 2. $96.353. All right, so 8.01. Oh, and I'm going to go back to the question up above as soon as we find these, because there's one thing I wanted to say. So 5 sine 8.01 divided by 2, what would that be?
8.01, 96.3531.
What was it?
96.3531.
353 what? 1. And then how about 8.001?
96.3492.
All right. So let's go back, before we go any further, let me go back to this question. So
The last one. I think it would be better to round it to 96.349 because when I got it, that's what it would round to when I did it.
that number there tells us something else, right? Because it's positive. And let's add that to our notes. Because average rate of change is greater than 0. Actually, I don't think I need the word is greater than 0, the rate is increasing. Right? So if your average rate of change is positive, the number of cars is increasing. If it were negative, the number of cars is going down. Right? So the cars are getting through, but it doesn't seem like it's increasing by much, right? It doesn't seem like it's increasing by much. Now, I'm no expert in traffic, so it's just my opinion. All right, so now let's take a look here and let's find out how many cars are getting through. All right, so we've got the average rate of change for f of 8.1. Actually, I'm gonna have to plug the. We have so little space here. Normally, I like to write it like this, and you should write it like that. But we have so little space, and we're doing 3 of them. Let's just plug in the values. So this is number 1. This one's number 1. So that would be from this time span here. So that would be 96.353 minus 96.348. And that's divided by, not much, 8 divided by, so 8.1 minus 8. All right, and somebody plug that into a calculator. Bye, Bella. What do you get when you plug that into a calculator?
You get 0.043.
0.043. Did you divide that by point?
Yes, I did divide by point.
Okay, 0.043?
Yep.
All right, and let's do the same thing, but this one is number 2. So this is our average rate of change is 96.3531 minus, so it's, there's 2, minus 96.348 divided by 8.01 minus 8. What do we get for that one?
Would be 349.3488.
And then divide that by 0.001.
Wait, which one are you doing?
This one. So this one here. So we have 96.3. Oh, I plugged in the wrong value. I'm sorry. Did I? Oh, no, I didn't. Did I?
Yes, you did. It would be
No, I'm okay. Oh, no, I did. Yeah, I'm okay. So 96.351 minus 96. Oh, I'm missing an 8. Now I'm okay. 93.9.3488 divided by 8.01 minus 8. All right, so what'd you get for that one?
I got 0.04.
0.04. All right, we're going to do one more.
And the one after that is 96.3488 minus 96.3488, so we've got 0.
All right, so the next one was 96.3492 minus 96.3488 divided by, and this would be 8.001 minus 8. You got 0. How many decimal places is yours rounding to?
9? I'm rounding 4 decimal places. I got 96.
Oh, round more. Round more. Because it won't be, it should be something.
I got 4 decimal places.
Yeah, don't round at all. Let me see if it gives us anything. But it appears to be.
8.001.
So yeah, it should be.
Yeah, I got 96.3488258956, which is very similar to the thing I got for just 8.
Someone threw the. What'd you? Somebody else plug this in. Let's just check this number here. 96.3492 minus 96.3488.
My problem is I'm not getting 96.3492.
You guys gave it to me.
I get, the number that I have is 96.3488.
No, I don't think they're the same.
Hey, I got 0s.
I think it depends on your calculator. If you have it set to round to 4 decimals.
I don't have it set to round to 4 decimals. I just have it set to show as many decimals as it can.
Huh.
Myself.
We got 0.04. Oh, you got 0.4.
I got 0s.
I also got 0.
All right.
But I rounded to 3 decimals.
Let's try this one again. The last one is our issue here. 96 plus 5 sine. And this is, so 8.001 divided by 2. I don't get nine. I got a weird number. All right, let's try it again. 96 plus 5 sine. All right, so 8.001 divided by 2 is 4.0005. Yeah, I actually, when I plugged that in, I got 92.214 for that number.
I couldn't think of that. That doesn't make any sense.
Okay, I'll do it.
All right, we have an issue with our last number. So, we are going to pause on this problem, come back to it. Let me see if we can get the rest of this done. And once we figure out our issue with 8.001, when I'm not being recorded, then we will finish up the very last section of this. But so far, it looks like, well, from our other two values there, that maybe we are approximating about 0.04 cars per minute. Actually, and that is an increase of 0.04 cars. So this rate, your average rate of change, if it's positive, is an increase. It's like a slope that's increasing. All right, let's do one that doesn't have any context to it, just with an equation. What about the rate of change of a function at a point? This tells us about the rate at which the output values would change were the input values to change at that point. We can approximate the rate of change at a point by using the average rates of change over small intervals that contain the point. All right, so we're going to come back to that other problem. Something is wrong with our values. I'm going to take it off recording. We'll figure it out and then we'll just tape the rest. All right, so we want to estimate the rate at x equals 1. So we're going to find values that are very close to that. So let's do something that's just a teeny bit less than 1. Let's find f of 0.999. And then let's find f of something 1.001. So somebody could plug this into the calculator. All right. Can I get two people to plug, one person to plug the one in, the top one in, one person to plug the bottom number in? Okay. Our calculators, we're getting lots of exercise today. I'm going to actually use, can I borrow your calculator? All right, so I'm going to borrow this calculator. Which one are you doing?
Top one.
Top one? I'll do the bottom one. 1.001 squared.
I've got 2.998.
Hang on 1 second times a half. All right, and then I got to add plus 3 times 1.001
Oh,
minus 0.5.
wait, never mind. I was about to add the negative.
Uh-huh.
Not gonna finish that.
So I've got, can you read that number to me?
Yes.
What decimals after the 4?
Yeah, it's 0.0005 after that.
Zeros after that?
Yeah.
All right.
Do you want 4 decimals?
Yeah. Actually, what we should try to do, though, is not round on intermediate computations. Because if you round on intermediate computations, that's where you lose. There's like rounding error. So what comes, that means we want as many as possible. The way you can do that is to keep everything in the calculator, but sometimes it's hard to keep everything in the calculator.
It looks, it kind of looks weird. Does it look to be a terminating decimal?
All right, so we got 3 zeros and a 5. All right, I'm going to include all of them. All right, so there it is. We'll include all of it.
That is a big.
Actually, it's just a teensy bit more than 3.
I got
Yeah.
1.1979999.
How are our numbers so different?
I think there's a problem.
Did you make sure to add the negative in the 1/2? Because it's -1.
Oh, no. I forgot the negative. Well, that's going to change the number tremendously. Tremendously.
Edit it. All is going to be hard.
Yeah. All right, 1.001 squared. And then times negative 0.5. All right, and then plus 1.001 times 3 minus 0.5. All right, so I get 2.0019995. All right, now what did you get for the top one?
1.9979995.
All right, 1.99979995. Okay.
It's just 2 nines for the first one. 1.997. 9995.
997.
9995.
9995. There we go. Oh, that looks much better. That looked very close together. And if we were to plug 1 in there, we would get 2. So F, our rate of change, at x equals 1 is going to be 2.001995 minus 1.9979995, all divided by 1.001 minus 0.999. All right, what do we get for that one? And by the way, instead of an equal sign here, it should actually be, it's still an approximation, although it's pretty close. What was it?
Making sure I get the numbers right.
Okay.
You know what? I might want to add a decimal place in there so it starts considering it thousands. That is a major difference.
Yeah. Oh, I forgot to write in a 9 in there.
So that makes more sense than becoming
Yeah. 2.001995 minus 1.9979995.
Really get .00320045.
Point zero zero. What was it?
00320045
.00320005.
over .002. Let's here.
Yeah, let's put the final number in.
The final number is 1.600225.
1.6. All right, so that's not the value of a function, right? That's our rate of change. So,
Not average rate of change?
no, that's like the almost the instantaneous rate of change.
Ah.
Almost the exact rate of change. So,
So can I phrase it like this? Honestly?
that's fine. Yeah, that's fine. Yeah, ROC is fine. So that's a rate of change. So as x is increasing by 1, that's what y is increasing by. Right. So at 1, that's how much our y values are increasing as our x value increases. All right, so I'm gonna see. I guess I can go for another 7 minutes. We'll leave this on. All right, so did I put this one in your notes? Yes. Okay. I'm going to do a lot of calculator stuff today. We got 4 more, and then a practice, and then a word problem that we'll do tomorrow. Okay, we got lots of calculator practice. All right, so these numbers are going to be really, really close. All right, at least they're not very long equations. All right, so we're going to estimate the rate of change at the given point. So I'm going to put in a number that's like 1,000th less and 1,000th more. So we're going to need to find f. So our rate of change at x equals 4 is approximately what we'd get for f of 4.001 minus f of, I wonder if we should stay closer than that. I went on either side. Let's do f of 4. I didn't think of that over here. So we did, I could have even done, instead of this number here, I could have even done f of 1. Let's see what we'd get if I did f of 1 instead. If I did f of 1, this would be 2.00999, oops, no, missing a 1 there. Sorry, people. It doesn't like it if I pick up the... All right, so 2.0019995 minus, if I plug in f of 2 or f of 1, f of 1 was 2. So if I used 2, I'd be even closer. And then this would be 1.001 minus 1. So somebody plug this into a calculator. 0.00199. Actually, I don't think I need you to. Let me see the difference. 0.0019995 divided by 0.001. I'm just going to have to move a decimal point 3 places. 1, 2, 3. So that would be 1.9995. Oh, that's much better. I was too far away. Now, what I should have done is done this one and done this one here minus 2. And I probably will get the same answer. So just to fix yours, we're going to take this away. I'm going to have to warn the people that are writing this, that are watching the video, to wait until I realize, oh wait, I'm still too far away. I meant to choose it on either side, but still include 2. There we go. And then let's see if we get, so notice we're just about 2. If I did the same thing and I did 2 minus 1.99799995 divided by and that was 1 minus 0.099. That would be, I can't subtract in my head with decimals. Let me see. That would be what, 0.002? 002 0005? Do I have too many zeros on there? I think I have one too many zeros. Maybe that's right. And then, yeah, I think that's it. Divided by 0.001, and then I get 2.005. Oh, there we go. So it's just about 2, right? Because we know what f of 1 is. It's 2. So the trick of that is being really, really close. Sorry about that, guys. Let's go ahead and we'll finish up this one. Go back. I won't make you guys have to come up with your own numbers. I'll try to remember to give you numbers. Okay? Okay. All right, and then our last one. All right, so we have divided by 4.001 minus 4. So this is going to be fun. All right, so this would be 1 over 3 times 4.001. That's just the function, right? We'll just plug into that. Minus, and then we'll use a calculator. 1 over 3 times 4, all over 4.001 minus 4 is 0.001. That thing is a 4, not an 11. I tell you what, let's just set it up, and then I'll plug it into it. How many minutes do we have left?
About 4 minutes.
About 4 minutes? I hate the plugging in, waiting for the plugging into the calculator. Takes a little while, doesn't it? Why don't we just set it up, and then I'll plug it into the calculator. And we'll do it from both sides. All right, so let's go the other direction. So this time it'll be f of 4 minus f of 3.999 divided by 4 minus 3.999. So that's going to be 1 over 3 times 4 minus 1 over 3 times 3.999, all divided by, and that's still going to be 0.001. And see if we get the same number as our rate of change at x equals 4. But we'll plug that in. I'll plug that into the calculator and give you the final answer. And then let's try this one. This is at x equals -2. So this would be f of -2 minus, actually let's make it -2.001 minus f of -2 all over -2.001 minus -2. All right, I'll plug it into this. I'm not going to even write it out because this one is a little bit longer. So we're just going to be plugging these values into that equation. And then we'll do it from the other side, which is f of -2 minus f of -1.999 all over -2 minus a -1.999. All right, we'll find out the answers to those exciting questions tomorrow. And so I'm going to close. Bye.